Okay, welcome, and thanks for coming, and thanks for all of you who are watching this recorded webinar. Thanks a lot. We're in the week 8 webinar. We're getting towards the end, and let me share my screen to show you the plan for the day. Okay, so as always, we'll start out with Q&A. And today actually is not that hard a day if you understood last week, because it's a little adjustments to last week's stuff to be able to do more. So last week, if you remember, we did hypothesis testing, but we only did hypothesis test to see if this proportion is bigger than a certain known proportion, or if this mean is bigger than a certain known mean. But in the real world, that's not usually what you do. Usually you want to compare. Usually you compare, this year versus last year, or maybe California versus New York, or, men versus women, or whatever it might be. But you're going to be usually doing a comparison between two groups. Okay. Or maybe before and after kind of comparison. How did the person do before they studied versus after they studied, whatever it might be. So what we're going to be doing today, and I should probably write in hypothesis test and confidence intervals. For the difference between two proportions. We'll also look at hypothesis tests and confidence intervals. For the difference between two means. And that's when we have what's called independent data. And that's kind of the main new thing that's going to happen today. We'll get into that, is dependent data versus independent data. And then we'll look at hypothesis tests for the difference between two means when they are dependent, and also confidence intervals. Once you have one, it's easy to get to the other. Okay, and then, this isn't March 20th. Sorry about that. We will have a not final discussion, but the main discussion on Project 2. I kind of hinted at it last time, went over a tiny bit of it, but this time we're really going to get into it, because Project 2 is all about this chapter here, chapter 10. So we're going to be looking at the project, which you're going to have to do a hypothesis test and a confidence interval for the difference between two means. And that's what Project 2 is about. So that is the plan today. And just let you know, I'm going to give you, the last few years, it's been one of my favorite examples. And it's my favorite. Any guess why? Fun? No, not quite. Huh?
What was the question? Your favorite what?
One of my favorite examples, statistics examples. All right.
Cat related?
All right. If you don't know why, let me tell you. Because of it, I made several $1,000s. And that's always a good thing, at least for me. So if you can make lots of money, so I'm going to be talking about the stock market, but a personal thing that I did that no one else in the world, I think, realized and made a lot of money on, which is always good. Maybe you'll learn how to make money too. You just have to find something like what I found. So I'm going to show you that. It won't work now and we'll see why. I'm not going to tell you now. So let me ask you, are there any questions about anything?
I had a question for Project 2. Can I ask it right now, or should I wait till the end?
Yeah, you can ask, but I might tell you we'll talk about it in very big detail pretty soon.
I just want to know, do we have to conduct another survey, or can we find data that's already been found online and use that data?
Yeah, you can find data, and I'll talk about the requirements of the data. Yeah, so this is very different than Project 1.
Okay.
Yeah.
So we don't have to ask people.
You don't have to do a survey. You can if you want to, but you don't have to do a survey. So that's totally up to you. And I'll
Okay.
give you some examples. There's been some very good examples of projects that didn't involve a survey. As in, I say a survey where you ask people. Okay, there's a survey where you actually look at data. That's also called a survey, but that's probably not what you're thinking. Okay, but you have to collect data. That's important.
Right. No, I get that. Yep.
You still have to collect data. You can't just find statistics that someone else did. You have to collect your own data.
Right. It needs to be raw data sets.
Exactly. And we'll talk about it in detail, I promise, today. Okay, but it's a good question, but I'm going to hold off on it until we get there. And then I promise you'll get it. Okay, you may still have questions, but the main points will be there. Any other questions?
I was a little bit unclear on when there's a claim, which one do I turn into the null hypothesis?
Okay, so the first thing is the null hypothesis always has an equal sign. That's
Okay.
one.
Mhm.
The null hypothesis is what you're trying to show is not true.
Okay,
And the alternative hypothesis something is what you're going to try to show is true. And you can never show something is exactly equal because unless you have a census, because if you think it's exactly 50% of the population of America, and even if you asked 1 million people, still won't know if it's exactly 50%. Because it might be off by one person. Does that make sense?
yep, okay.
Yeah. So null hypothesis always has an equal sign. Okay. And we're going to see there'll be more verbal language next week, but it'll mean equal, but we'll use words, but that's next week, not this week.
Okay.
But good question. And other questions?
I had one question about your post.
Mm-hmm.
I think Jenny actually asked it, and I'm not sure if you respond.
You just want to
Yeah, where did he get the 0.3 from?
Yeah, where did you get that 0.3 from? I was confused about that too.
Honestly, I don't exactly remember my post. It came in there somewhere. Just a minute. Discussions. I don't remember every detail. Sorry.
No, I understand. I was just asking. I was thinking
sorry.
about it too.
The week 8. You mean this week's post?
No,
it was from last-
Last week's post.
Last week's post.
So last week's post. So let me look at it. And let me find the 0.3. Okay.
on the bottom.
Okay. So the bottom.
It was the bottom part.
Right here.
Yeah, that part. Where did you get 0.3 from?
That came from the article itself.
Okay.
So the article itself showed that that's how much higher the sample mean was for racism for girls versus boys.
Okay, so it wasn't something you calculated.
No, it wasn't. No, I mean, they calculated it and I read the article and I found it.
Yeah, I almost feel like the hardest part of that discussion was trying to sift through all the language in it, you know?
Yep.
That was the toughest part. It was like,
yeah, you got a lesson in how detailed and how difficult it is to read a true journal article, which is different than a news article.
yeah, I didn't even know people were conducting some of these studies. Like the one I read was about the 3rd trimester of COVID in women in China. It was like so specific. I was like, who's researching this?
Yeah, so that it's done a lot. And in particular, if you want to get a master's degree, you have to do some specific research typically.
Right.
So that might be someone's master's thesis. Or if you're a professor at a university, not a community college, I don't have to, but if you're a university professor, there's something called, I don't know if you've heard of this, publish or perish. Have you heard of that?
Yeah.
Yeah.
That means that
Publishing.
every single professor has to publish journal articles that are very specific, or they don't get tenure.
Hmm.
Right.
So there's a
That's where
lot.
that come from then, huh? Because I was blown away by how specific they were. I was like,
Yeah. And usually that happens from someone getting a master's or a PhD, or somebody working to get tenure, and they do some very specific study and they write about it. But that's not part of our class. We don't have to worry about that. But if you decide you want to get a PhD, then yeah, you have to do that. Okay, yeah, so sorry if the 0.3 was confusing. It just came from that's what they had. I just copied it and pasted it, basically. It was in there. Okay, shall we continue on?
Yeah.
There we go. All right, so the great thing, as I mentioned, what I really like about this class, and especially the last half of the class, is I have no trouble finding examples of what we're doing, whatever we're doing that are current. And so I'm going to start out with a current event. So here we go. Is there a difference between Democrats and Republicans for whether they favor a limit on how long SCOTUS, Supreme Court of the United States, if you didn't know what that meant, that's what it means. So Supreme Court of the United States justices can serve. Okay, so I don't know if you know about our Constitution. I think it's in the Constitution. Do you know how long a Supreme Court justice can serve now?
Life?
Yeah, until they die. And then, by the way, after you die, you can't serve anymore. But basically, if somebody is put in when they're 45 and they live to 90, they're in for 45 years. Okay, and that's all part of our law. And the question is there a difference, or my question, is there a difference between Democrats and Republicans for whether they favor a limit on how long they can serve? Okay, shall we pass a law? Okay, and it might need to be a constitutional amendment. Okay, also interpret the 95% confidence interval. Any questions on the question?
No.
Okay, so let me just show you. And I don't think I brought this particular one up yet, but this is the Quinnipiac poll, Quinnipiac University poll. They do some great surveys. And nearly 7 in 10 favor a limit on how long the Supreme Court of the United States justices can serve. Okay, which is, 7 in 10 is a lot. Now, the question I had is not, is it a lot, but is there a difference between Democrats and Republicans? Does that make sense? And I'm not going to get into, all the details of this article. It goes on and on, but it does show that Democrats support it, 77% support it, whereas Republicans, 61% support it, having a limit in how long the Supreme Court justices can serve. Okay, and this is, this is very current. I think they finished this thing in May, and we're still in May, just to give you an idea. It's not an old article.
What does it mean, 77-18%?
Oh, that 77% supported it, and 18% were against it.
Oh, okay, gotcha.
Okay, and that means probably 5% were neutral.
Mm.
Okay, and similarly, 61% of the Republicans were for it, 36% were against it, and that would be around 3% were probably neutral. Does that make sense?
Yeah.
Okay, and I can get independents. It turns out there are ways of doing it with Democrat, Independent, Republican, but it's really beyond this class. Okay, you can do it with chi-squared, which will not happen next week. Okay, and that will work. And we'll talk about that next week. But this week, we're just going to do Democrats and Republicans. Okay, just to make it easier. Any questions so far?
Mm-mm.
Okay, so now what you do, we're going to follow the way of doing things. Okay, and the way of doing things, what's the first thing you do in doing a hypothesis test? And I'm also going to do a confidence interval too for the difference.
State the hypotheses.
Exactly. We're going to state the hypotheses. And it's going to look a little different than last time because we now have Democrats and Republicans. So last week, if you remember, we would have like P equals 0.3. But now we have Democrats and we have Republicans, and each of them have a proportion. Does that make sense?
Mm-hmm.
There isn't some number we're comparing it. We're comparing each other. So our H naught will be, I'm going to call it P sub D, which is a proportion of Democrats who favor having a limit on the time at which a Supreme Court member can, serve. And P sub R, I'm going to call that the proportion of Republicans who favor having a limit on the time at which the Supreme Court justices can serve. Any questions on the notation? Okay, and P is a population proportion, by the way, not the sample proportion. Any questions?
Is it always a population proportion?
No, because in just a few minutes, we're gonna do a population mean.
Okay.
Yeah.
But is it ever a sample proportion or sample mean that's used for the hypothesis?
No, because remember, a hypothesis means that you are thinking it might be true. You're going to do some studies, and then you're going to say, yeah, I think it's true. I'm pretty sure. But I don't know for sure, but I'm pretty sure. Does that make sense?
Yeah.
Well, if it's a sample,
You already know if it's a sample, right?
I know 100% certain that in the sample, more Democrats than Republicans, right? Higher percentage Democrats than Republicans of the sample support having the Supreme Court justices have a limited term of office. Does that make sense?
Yeah. Okay.
You don't need to do a hypothesis test when you know for certain.
Mm,
Whereas
okay.
the population will never know. There's no way we're going to be able to survey every Republican and every Democrat in the United States. It's not possible. Does that make sense?
Okay. Yeah.
Yeah, so it's always going to be population for that reason. And I do want to give you a big heads up because I noticed this, a few people made the mistake on the discussion post for the one I just looked at. And that is, don't get confused between proportion and mean, okay? And that actually, it was a discussion post and even more for the exam.
Mm.
Exam, which is make sure that this is a proportion, because what is the survey question?
Yes or no, or do you agree or do you not agree?
Yeah. Do you support having a term limit for the?
The answer is yes or no.
Yeah, the answer is a yes and no to the survey question. Okay, do not use the word mean if the answer is a yes or no. And do not use the word proportion if the answer is like 23. Does that make sense?
Yeah.
Okay, very, very important. And again, multiple people made that mistake, and that's why I'm spending time and repeating it a bunch of times, because you just got to get there. Okay, and it's going to happen this whole class. And by the way, next week, we don't do either of those. We have another kind. Just to make it more confusing, not because I'm trying to be mean, but just let you know it's part of the class. So there's survey questions that aren't yes, no, and there's survey questions that aren't number answers. And that's next week. We'll get there. Okay. This is political science. Hopefully you all know that this is a political science question. And political scientists pretty much always use a 5% level of significance. Any questions on that?
It's because the type 1 and type 2 error are equal in terms of.
Yeah, they're basically equal. You're doing a report for the news and you're wrong. One way or another, you're wrong. Does that make sense?
Mm-hmm.
So you typically just do a 5%, and that's just standard. Okay, so definitely 5% on this one. Okay, so the next thing we need to do is we need to find the p-value. And hopefully you have an idea of how we might go about that.
Okay.
Yep, the calculator. Okay, so we can look at Democrats first, and there were 403 surveyed, 77% supported it. So I go to the calculator. Tell me which one you think it might be.
Hypothesis test for proportion, number 16.
Good
Oh,
try.
no. Oh, wait, it's 2 independent samples with, so it would be 18, no, 19.
Yeah, it's 19. It's 19, not 2 independent samples. It's 19 because it's 2 proportions. So notice that 16 is 1 proportion. The word A is really important. It's easy to not notice a single letter word like A, but that's a very important word, A. That's a single proportion. We have 2 proportions. Any questions on that? Okay. And I'm going to click on that, and you're going to notice that this does both confidence interval and it does the p-value. And that's why I didn't write hypothesis test proportion. It just does it all. Got it? And for two proportions. I just wrote two proportions. Okay, so in our first sample, the sample size again was 403. The number of successes we have to work on a little bit because we're only given 77% because that's what the news article told us. But how do you find the number of people who said yes if 77% said yes out of the 403?
3 times 0.77, which is 310.
Yeah. And as I meant, as you've seen in all of these, hopefully you've noticed there's always a button for scientific calculator so that you can always just go to it. And it's, you always want to round to the nearest whole number when you're talking about proportions because you can't have 0.31 people say yes. So 310. Sorry, that's the number of successes for the first sample. Okay, the second sample had 384 Republicans. Oops, this one, sorry, 384. And of those 384, 61%.
That's 234 yeses.
Okay, wow, you can do that in your head. That's pretty awesome.
No, I'm doing it on my calculator.
Okay.
Does it save us time?
I do like to show you on this so that those who are watching and don't like realize you can notice that you do use a calculator. 0.61 and whatever calculator you want to use is just fine. But I tried to import an easy one. You just type it in and it just shows it to you. And that's 234. Okay, we have to decide, is it less than, greater than, or not equal to? And again, that was over here. Notice, by the way, there's a keyword here, and that's difference. If you want to find out if there's a difference, that's a not equal to. Any questions on that?
No.
So I'm going to go to the not equal to and click on that. What do you think a good confidence level is?
95%.
Yeah, 95%, because that's standard. It's political science. 0.95 would make the most sense. Okay, any questions on that?
No.
And I hate calculate. And we look at this and we see that the p-value is really small. 5 zeros and a 1. So I can go and say the p-value is 0.12345 and then a 1. By the way, the p-value is not 0. Okay.
Oh.
It's 0.000001. I really want to emphasize, never say the p-value is 0, even if you do rounding. You can round and type in 0, but in words, you don't want to say 0. You could say close to 0, very close to 0, super close to 0. But if you say 0 and you announce it, people who know statistics are going to get mad at you because you can never have a p-value basically of 0. Do you see that?
Okay. Because
Okay.
it goes infinitely.
Yeah, you can always go enough decimal places and you'll find something non-zero.
Right, because there's always a slight probability that it'll happen. Right?
Exactly.
No matter what.
Yeah, there's always a small probability it could just happen. So there's our p-value, but it's certainly much less. I'm going to use a double less than to say, just like scream that it's less than 0.05. Any questions on that?
Nope.
Okay. The good news, and this is what I mentioned at the very beginning, is that if you understood last week, there's very little new stuff to do. I mean, have you seen much new stuff today?
No, but I don't mind the review.
Yeah. But notice that, I mean, the only new is that the right-hand side of these hypotheses are not numbers. That's really the new thing.
Mm.
That's it. And the conclusion, same idea. What's the first word I should write?
There.
Huh?
There?
Yep, there. Nothing changes. And next word?
I don't know.
Is. Wasn't a trick question. And then I'm going to write strong. When it's really small like that, usually use the word strong, statistically significant. Evidence. Doesn't this sound the same as last week?
Mhm.
Okay. And you could even like really emphasize, say very strong if you wanted to, because it's such a small p-value. To conclude that, and now remember, keywords here is you have to emphasize that you're talking about the entire population and not the sample. And with proportions, usually I'll often use the word all. You can use population proportion, either way, that the percent of all Democrats who support, I think they call it term limits, what they call it exactly, just a limit, okay? A limit on how long SC
OT.
OTUS. I always have to think about the words and write it down. SCOTUS justices should be allowed to serve. Differs from, and I'm going to copy and paste, it'll go a lot faster. And change one word. The percent of all Republicans. Who support a limit on how long the Supreme Court justices should be allowed to serve. Any questions at all on so far in the hypothesis, the main piece of the hypothesis test, and that is writing down H0 and H1, finding the p-value and stating the conclusion.
When you write this out, do you have to define what PD, PR, PD, and in the hypotheses mean?
I did right here. All
Oh,
Democrats. Do you
yeah.
see?
yeah, I see what you're saying.
By writing the percent of all Democrats, and you can use proportion, it's the same thing. It's the same idea, it's multiplied by 100. So the percent of all Democrats, that defines it right there. But if you don't use the word all, you haven't defined it right. Does that make sense?
Yeah.
You could also write population proportion of Democrats who, that's the same thing.
Okay, I got you.
It's English, and there's different ways of writing English stuff. Any questions on this?
Hmm.
Okay, now I want to interpret the p-value, which is really, really small. What's the first word?
If.
Yep, if. Nothing's changing here. Okay, so if, and now I'm going to copy and paste because it's a whole lot easier. The percent of all Democrats who support a limit on how long SCOTUS justices should be allowed to serve is the same
Oh, okay.
as the percent of all Republicans who support a limit on how long SCOTUS justices should be allowed to serve. One thing I love about computers is you can copy and paste. And all of your work is on the computer, so I don't have to feel guilty about me copying and pasting, because you can do that for everything you do in this class. Okay, so limit on how long SCOTUS justices should be allowed to serve, and if another study of, and now how many do we have? 403 Democrats and 300 and.
It's okay that the number of people surveyed are different for each data set.
No problem.
Okay.
Okay. So another 403 Democrats and 384 Republicans were surveyed. Okay. I should mention this though, because you asked this question, and so it brings up something that's important. Do you remember the what you needed to have a large enough sample size to do this?
30, right? 30, well, more than 30.
Be careful.
More than 5.
Yeah,
Oh, that's right. I
don't
made the
ever
mistake
say
you
the
told me
number
not to
30.
make.
Don't ever say the number 30 when we got proportions.
Okay, okay.
Yeah, and it's not the sample size is more than 5, but
It is
you have to
the
make
P
sure
and
that
Q.
310 is more than 5, and also 403 minus 310 needs to be more than 5, and also 234 has to be more than 5, and 384 minus 234 have to be bigger than 5. Does that make sense?
Yeah.
So in before last week, we had to make sure that NP and NQ are both bigger than 5. So now we have to have that NP and NQ are both bigger than 5 for both groups. Does that
Okay.
make sense?
Mhm.
If we got the Democrats and Republicans, when you're doing a comparison study, you have to make sure that all of your NPs and NQs are bigger than 5. So there's more of them to deal with. Any questions on that? Okay. And I'm also going to let you know that typically a good study is going to have around 1,000. So, which is why I am not going to have you do that for your project, because that would be evil. So we're not going to be doing a proportion study. We'll get to what we're doing in a minute. Okay. So let's continue reading again. So if the percentage of all Democrats who support a limit on how long SCOTUS justices should be allowed to serve is the same as the percentage of Republicans who support a limit on how long SCOTUS justices should be allowed to serve, and if another 403 Democrats and 384 Republicans were surveyed, then there would be basically almost no chance, or 0.1234.
5s and then 1.
Yeah.
I think you need one more
5.
0.
One more 0.
Wait. No, you move the decimal over 2 places. It's not enough zeros.
Oh,
Oh, I see.
Percent.
You're doing percent.
I'm about to get percent chance,
oh, I see. Okay.
which is almost no chance that the new study would end up having a difference in the Democrat and Republican proportions of at least 16%. How'd I get the 16%?
Yeah.
Take a look.
Is it because it's 77 minus 61?
Yep, because that's how different they were in our survey. Do you see? And it's always at least as much as what our survey got. In this case, we got a 16% difference. Okay. So if they were equal and you surveyed, it's a very, very, very small chance you get at least 16% as a difference. Any questions on that? Okay, just a note, I want to mention this because it's very important for the project, so listen carefully. When you have such a tiny p-value, you hardly worry at all about a type 1 or a type 2 error. And in fact, type 2 error is impossible because type 2 error is when you fail to reject the null hypothesis, but then the null hypothesis was false and that we didn't fail to reject, right? A type 1 is when you reject the null hypothesis, which we did, but the null hypothesis was true. Does that make sense?
Yeah.
So that could happen, but with our p-value so minusculely tiny, that chance is so small, it's not much of a worry at all. Does that make sense? You can be like so comfortable about this. Okay, so you wouldn't even think about doing another study with a bigger sample size, so you can be more confident because we got a big enough sample size. Do you see? You got such a tiny p-value. Whereas if you got a p-value of say 0.04, 4%, then you worry a bit about the type 1 error. Do you see that? And if you got a p-value of say 0.06, then you would fail to reject and you worry a lot about the type 2 error. Do you see how that works? Whereas if you got a p-value of say 0.9, a type 2 error could happen, but it's very unlikely because the P is so big.
Mm,
I have an analogy I like to use because it's easy to remember. Imagine you are the coach of a soccer team. Got it?
mhm.
There is 1 minute left in the game, and you're ahead by 1 point. Got it?
Okay.
And I'm sorry, you're behind by 1 point.
Oh, okay.
You're behind by 1 point. And your, player is about to kick the ball, and the other team smashes that guy or that woman. Got it?
Okay.
And the ref doesn't do anything. Should you petition and get upset at the ref and say, hey, you should look at the video here?
Yes.
Yeah. And the reason is, if you don't, then you lost the game, right?
Mhm.
But you really think that you should have won the game or at least tied. Does that make sense?
Yeah. Okay.
Okay, so that's one. So that's like
Especially
the
in this-
p-value. That's like the p-value being, say, 0.06. Got it? Is that clear?
Okay.
Yeah,
Okay.
but if you're
Now
down by
let's-
10, it doesn't matter.
Yeah, if you were down by 10 and there was 1 minute left, and the guy, and the other team smashed your team member a little bit, no injury or anything, but made it so that your team member, your player couldn't kick the goal. Are you gonna scream and yell at the ref?
No, it's a blowout.
Yeah, you lost. Does that make sense?
So
Exactly.
0.06 is when you fail to reject the null hypothesis.
Right, and then you're gonna want to do another study.
Okay.
Okay. In my analogy, it's yell and scream at the referee, but in this analogy, if we had a 0.06, then you do another study. What if you're ahead by 10 and the same thing happens? Your
You-
player goes to kick it and they get fouled, but the ref didn't do anything.
Doesn't matter.
Doesn't matter. You're not going to yell and scream at the ref, right? What if you're ahead by 1 with a few seconds left?
Doesn't matter.
Still doesn't matter. So if you got even 0.04, then you're not going to need to do another study. Does that make sense?
Hmm.
But
Yeah.
the other team might do another study.
Ah, okay.
So you don't do another study because you're happy. You were able to publish your paper, okay, and say, yeah, we had statistically significant evidence. Do you see that?
Mhm.
But if it's 0.04, then somebody who is maybe not so happy about it might want to do another study to, make sure you're right. Does that make sense? But you wouldn't have to do another study.
When you peer review other people's works, do you check to see that data has integrity?
Has a what?
Has integrity and people aren't like messing
yeah.
with the data?
Yeah, and I have peer reviewed several works, and I have sent some back. Yeah, and I've also peer reviewed. I've also consulted for the Forest Service on other people's work, and let the Forest Service know that they can't trust it.
Oh, okay.
So I've also I've done that too, not just peer reviewed journal, but actually helping out with the Forest Service. Okay. I've also worked with, and I don't want to get political, by saying anything, but with the Democratic Party, and
Mhm.
let them know if they made a mistake.
Mm.
And actually, because of me, they changed who they supported, and that person won the Democrat ticket.
Hmm.
And had I not done it, a different person would have won. That kind of cool. Made me happy, but the person lost at the end. But
Mm.
at least I was able to get the right person to win the Democratic ticket.
Mm.
Okay, so that kind of stuff happens. Okay, any questions at all on this? Okay, now interpreting the level of significance, big copy and paste. Everything up to there would be. So let me copy and paste and read it again. If the percent of all Democrats who support a limit on how long SCOTUS justices should be allowed to serve is the same as the percent of all Republicans who support a limit on how long SCOTUS justices should be allowed to serve, and if another 403 Democrats and 384 Republicans were surveyed, there would be what is the level of significance?
5%.
5% chance that the new study would falsely, it's the same thing as we did last week, lead us to conclude
But there's a difference.
that there is a difference in the, and now I'm just going to copy and paste, percent of all Democrats who support blah, 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 and I'll put the word and is the same, except without the same as. So there is a difference in the percentage of all Democrats who support a limit on how long SCOTUS justice should be allowed to serve, and the percentage of all Republicans who support a limit on how long SCOTUS justices should be allowed to serve. Very little new compared to last week. Do you agree?
Mhm. Yeah.
Just a new calculator.
Definitely have a new calculator. We'll have a couple more too today. Just let you know that. Okay, now confidence interval. Okay, that's not going to be new, but it's been 2 weeks instead of 1 week since you thought about it, right? So we have our confidence interval and our calculator gave it to us. It's all in one calculator. And I'll go 2 decimal places. Sound good? So 10%, 0.1 to 0.22. Okay, and nothing really changes. What was the first word for confidence interval interpretations?
Therefore,
Good try, but no.
oh,
Start with a W. That's a hint.
Where? No, with.
With,
Oh, yeah, with.
with 95% confidence, we can conclude that the population proportion of Democrats who, and now let's copy and paste it. I don't have to keep typing it. Support a limit on how long SCOTUS justices should be allowed to serve is between. And now we can write this as 10% and 22%. That's turning those into percents. Larger than, and now I'm just gonna copy and paste and change one word. The population proportion of Republicans who support a limit on how long SCOTUS justices should be allowed to serve. Any questions? Any questions on the confidence interval?
no, makes sense.
Yeah, this is like a review of the last 2 weeks, isn't it?
Mhm.
But now we just have a comparison between two groups. But it's really the same ideas. Okay, and we're gonna have more same ideas next week, by the way, just let you know that. Some of the same ideas week after, and then the same ideas again the week after that. So this hypothesis testing and confidence intervals are really important. Okay, I'm gonna do this one pretty quickly because we only have so much time. Do single women spend more time cooking than single men? What do you think?
Yes.
Okay, we'll find out. But I want to let you know I made up these numbers. So
Oh, okay.
yeah, because we only have so much time, I can't go and read articles and stuff for you guys. The 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. And the 38 single men who surveyed averaged 46 minutes a day cooking. Their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the confidence interval. Okay, what's the difference in this example and the one we just did? What's the main difference?
This one's
Mean.
Yeah, this one's mean because the survey question is, how long do you spend cooking? Does that make sense?
Yeah.
And I spend, 42 minutes cooking, something like that. Okay, I don't say yes. Does that make sense?
Yes.
Okay.
Yes.
But we are comparing two groups. Okay. And I want to let you know, and this is really important, the individuals in the women's group are independent of the individuals in the men's group. Is that clear?
Mhm.
Yes.
Okay. If they had asked, say, only maybe husbands and wives, that would be totally different. So keep that in mind, and we're going to get to the dependent stuff too, because they would be dependent. But the first, in this particular survey, the first woman has nothing to do with the first man. Does that make sense?
Yeah.
Okay. Or if they did brothers and sisters, that would be dependent also. Is that clear?
Right, because if one is eating, the other one is like one is cooking, the other one is not cooking. So they would.
Yeah, it could
dependent.
happen. I mean, who knows with brothers and sisters? I mean, I'm cooking tonight, and my sister's probably also cooking tonight because she's, lives in San Francisco, and I, or in the Bay Area, and I live in Tahoe.
Okay.
So, but we could still compare, and we're related genetically. Does that make sense?
Yes. Okay.
But brothers and sisters wouldn't be dependent, would they?
Oh yeah, yeah, they're dependent.
Really?
Because
Even if they don't live together?
they're genetically dependent. Doesn't mean that you rely on each other. So be careful about the word dependent and independent. Do you remember this was in chapter 3, and you probably hate when I bring back something so long ago. We talked about independence.
Yeah, I remember.
It's that kind of independence. It doesn't mean that you're dependent on someone. It just means each pair has a relationship to each other.
Right. Okay.
Okay. And the typical independent are two groups that have the individuals have nothing to do with each other. Does that make sense?
Okay.
Dependent is when they have something to do with each other, or if it's the same person answering two questions. That's very dependent. So if they asked, do people spend more time cooking dinner than they do cooking breakfast? They asked 50 people, how long do you cook dinner and how long do you cook breakfast? Or spend, on each. Does that make sense?
Yeah.
That'd be dependent, because then that's each person would be doing two things. Okay, another dependence might be, let's say you wanted to find out, and I don't know if you know Tahoe area, but I'm going to give you Tahoe area. Who gets more snow in the in a winter storm? Kirkwood or Heavenly? Have you heard? I don't know if you're in Tahoe or not, but you've heard of Kirkwood and Heavenly?
Yeah. Kirkwood normally gets more snow.
Okay, well, how would you know?
Anecdotal evidence.
Okay, but how would you do statistical evidence?
Look
Oh,
it up on here.
Look up the data and then do a comparison.
Yeah, you'd look at say maybe 40 storms that happened, and then for each of the 40 storms, you'd look at Kirkwood's snowfall and you look at Heavenly's snowfall for each of those storms, and it's dependent because it's dependent on the storm. Does that make sense?
So, but it's not just enough to look at that data and be like, okay, it snows more at Kirkwood than it does at Heavenly.
It actually is, as long as that data is random storms,
So in that case, you wouldn't have to go through all this.
You go through a different calculator. It's just as hard.
Is it dependent because it's the same storm that's shedding snowfall on both
Yep.
locations? Okay.
Yep. And that would make them dependent.
Okay.
Does that make sense? I wanted to give you one that wasn't people.
Mm.
It was Kirkwood versus Heavenly, nothing to do with people, it's storms. Okay, so there's a lot of times when it's not people. Or another one that people have done for the project is, let's say you want to find out if Amazon is cheaper than Costco. Then what you might want to do is look at, say 35 different products that are sold at both places and compare the prices of those products. That would be dependent. Do you see that?
That's a good project. That's already been done.
Because it's the same product?
Yep.
That is a good project. Can we use it?
Well, let me get to the project in a bit, but I wanted to, again, today is project day, so I want to give you ideas and thoughts. Okay. Okay, so let's do this one. Okay, also interpret the confidence interval. So H naught now is mu W equals mu M. So that's mu for women equals mu men. Okay, population mean. H1 is mu W is greater than mu M because we're looking at the word
More.
Okay, always look for the right word. Okay, so now we got to find the p-value. So guess what we have to do?
Calculator.
Yep, so we go to a calculator and we go back to the calculator menu. See if you can guess which it is.
18.
One more time.
Oh wait, is it 18? I don't know.
Yep, because we have statistics, we don't have data, and they're independent. So it's 18. So now we have to fill in the blanks. So the sample sizes were 35 and 38. The means were 58 and 46. Sample standard deviation, they were 12 and 16. Our hypothesis, alternative hypothesis, had a greater than. So I click on greater than. We want a 90.
We need to make sure the women are on top, right?
Yeah, that's important actually. Otherwise, it would be less than.
Okay.
Its first is greater than the second.
Okay.
Is how I programmed it. So that's just a note. Okay. And where are we? We want a 95%, so 0.95. And I calculate. Any questions on this? And what do you see for the p-value?
It's low.
Yeah, it's low. Okay. And for time reasons, I think I'm just going to say the answer here. Our p-value is 0.0002. So there is, what are the next two words?
A strongly statistical evidence.
Yes, statistically significant evidence.
Yeah.
Word significance important. There
Okay.
is, in this case, strong because it's much less. It's a very small number. Strong statistically significant evidence to conclude that the population mean amount of time women spend cooking is greater than the population mean amount of time men spend cooking. Is it feeling the same as last week?
Yeah.
Okay. We just now have two variables instead of one, basically. That's the only difference. Any questions on this? Okay. Then the lower bound and upper bound is, I'm going to do nearest whole number, 5 and 19. So now with 95% confidence, the population mean amount of time that women spend cooking is between 5 and 19 minutes longer than the population mean amount of time men spend cooking.
Okay.
So it should sound very similar to that. That was 2 weeks ago, though.
Mhm.
Okay. By the way, if we got a -5 and an 18, then you would say that women spend between 5 minutes less time and 18 minutes more time. So know how to deal with the minus and negatives and positives. Does that make sense?
Yes.
Well, that's good to know.
Yeah. So I figure I better tell you one if it's got a negative and a positive. All right. You ready for the example that made me thousands of dollars?
Yes. Give it to us.
Okay. So I want to let you know, I never tell you to vote for who to like, but there's always good things about anybody. And I call it playing the tweet. So I'm going to tell you the story. It's my favorite one. So this was a few years ago. Okay. It's about 4 years ago, actually. And who was our president?
Trump.
Trump. And he was really into Twitter. Do you remember that?
Yeah.
Oh yeah.
And he used to tweet all kinds of things about how he hated China. And he was going to do these awful things to China. Do you remember that?
Mhm.
Okay. What I did is I took some statistics and I looked at the stock market the day he did that tweet Okay, so like a couple hours after he gave the tweet about China. And then I waited another week and looked at the stock market a week later. And what I noticed is that it looked pretty consistent, that the stock market went way down on what I call tweet day. And then it bounced back up a week later, that everyone overreacted.
Huh.
And I found, anyone know what this is? NVDA?
Hmm.
NVIDIA, have you heard of that?
The chip company.
The chip company. And I found that the chip company NVIDIA, its stock reacted more than any other stock I could find. So what I did is I collected a sample. This is an example where, is my sample size large enough to like publish a paper? What do you think?
No.
No, but if I wanted something over 31, why would that not work? Should I tell you? Because Trump wouldn't be president anymore.
Oh, yeah, right.
He didn't do 31 sheets about China where his work. Do you know what I mean? So I just did.
Were the tweets, did they have to be about China?
Yeah, they did, because that's what I found. There was a big reaction in the stock market when it was about China. Okay. It was about, if it was about something that had nothing to do with financial trading, then no one cared. Okay. But the China, this is just what I found. This is not a statistics thing. This is just my personal finding. So what I did is I looked at the data and I did a small sample size because I wanted to make money and I didn't want to wait till it was over.
That's
Yeah.
funny. Did you vote for him again just so you could keep playing this?
I'm not supposed to get political, but oh no. Remember, I worked for the Democratic Party. So, again, I'm not going to tell you to vote for. I can't do it. I will tell you to vote, by the way. Okay. All right. I almost lost an election because my students didn't vote. I won by 3 votes. And I would have won by 20 votes or 30 votes had my students voted, but none of them voted that year.
Oh.
So you should vote if you're allowed to vote. But I don't tell you who to vote for. Okay. So we're going to have, so this is different. I'm going to have mu sub D. What do you think D might stand for here?
Donald Trump tweets.
Good try, but no.
Hmm.
This works on all examples.
Difference. Is it difference?
Difference.
Oh, okay. Yeah.
So it's the mean difference is equal to 0 versus the mean difference is less than 0. Okay. So first thing, one way of kind of seeing if it should be less than or greater than, or think of an example that supports your H1. So for example, when it went from $106 to $113, that was good for me, right? That supports my H1. The stock market went up. If I take 106 and subtract 113, I get a negative number. Do you see that?
Hmm.
So that's how I know to put a negative, a less than 0. Do you see that? It's
Hmm.
good to see an example that actually works for H1 to decide whether it's a less than or greater than. Okay, especially when you're doing this type of thing. Any questions on that? Okay, and by the way, assume, big old assume, the distributions are approximately normal. So I want to note there's an S here. Why is there an S?
Because there's
More than
2.
one distribution.
Yeah, there's 2 different distributions. There's the distribution on tweet day and there's a distribution 1 week later. So whenever you're talking about this chapter, you got to talk about both distributions. Does that make sense?
Hmm.
Okay. So what I do is I have to go to the correct calculator. And what do I go to?
17.
20?
Okay. Are these independent?
No, they're dependent actually.
20.
Then it can't be 17.
Okay. 20.
20 it is. Okay. Does that make sense? It's
Mhm.
2 dependent samples with data. So I click on that. And this is very similar to the one. I'm going to copy and paste and stick commas in is the easiest. And then I go to the other one. I'm going to copy and paste the other one. Okay. And then we had a lesson. So lesson's correct. Any questions on that? Let's do a 95%. Actually, let's do 90%. Again, we have a small sample size. This isn't something that with stock market, you can never be that confident. Does that make sense?
Hmm.
And hit calculate. Okay. And by the way, the test statistic is T. I didn't mention that, but same idea as before. The p-value, what do you think? Is it small enough?
Yeah, 1.8%, right?
Yeah. And by the way, think about the errors. A type 1 error. What happens? What's the damage to me for a type 1 error?
You think there's a difference, but there's no real difference.
Yeah. And what am I going to do if I think there's a difference?
Buy.
I'm gonna invest.
I'm going to start investing every time. And guess what? I'm not going to make any money. Does that make sense?
Yeah.
How about a type 2 error?
There isn't a difference. You don't invest and you don't make any money.
Right. When I could have made money. Do you see that?
I also don't lose money.
You don't lose money, but you don't make any money either. Does that make sense? So
Yeah.
they're both pretty bad, right? One is you don't make money that you could have made, and the other is you don't, that you thought you were going to make money and you didn't. Right? So either way, 0.01, 0.02, that's good enough, especially with a small sample. Okay, the lower bound for the mean was $13 a share, by the way. And the upper bound was $2 a share. Okay, that's what these numbers represent in this case. Is that clear? So there is statistically significant evidence to support the claim that the population mean stock price of NVIDIA 1 week after Trump's tweet was higher, okay, than the population mean stock price at the tweet. Okay, so the day of the tweet. Any questions on that? Okay. Not only that, we have a -13 to a -2, and that's how that negative. It seems a little weird because you're going from, if you go from low to high, that's negative. So that's how. So -2 means you made $2, by the way, a share, and -13 you made $13 a share. It feels wrong, but that's how it is. So what we can say is that we're 95% confident that the population mean stock price is between $2.24 and $13.42 higher a week after the tweet than during the tweet day. Does that make sense?
Yeah.
Okay, so at that point, what did I do?
Buy.
I bought every time he tweeted. Okay, about China. And guess what happened?
Made money.
I made thousands of dollars. Okay. And again, I haven't found, Biden doesn't tend to tweet. Biden doesn't say really loud things that everyone gets all, worried about. So again, I'm not saying, Biden's good or bad, but I'm just saying they have very different personalities. Do you agree? So I haven't found anything with him. But, I still make money in the stock market. It's been a tough year though. I have done this also with protests against certain companies where the protests were kind of worthless. And I've made money that way too, where I did the statistics, I ran the statistics, I showed that it was statistically significant, and that's when it's time to make the money. Any questions on that?
Couldn't you just do it with like normal news articles too? Like if a news article is bad or good or.
You could do that. What I found is that everyone knows about those. People
Yeah,
find out too fast.
yeah, for sure. That's how everybody trades, huh?
Exactly. I have to do something other people haven't seen yet.
Yeah, absolutely.
And I don't understand why no one noticed the tweeting thing, but no one noticed. I never talked to anyone who'd also do what I did.
That's really
anyway,
cool, man.
It worked. Yeah. And it's not like I can do this every week. I have to find things. And here and there, I find things. Okay. And they work. Okay. I'm not a billionaire, but I probably would be if I decided not be a teacher. Just let you know. But, you know, I make good money in the stock market. Okay. Any questions at all on this example? Okay. So notice again, this is dependent data because each tweet has two numbers. Does that make sense? Any questions on why this is dependent? Okay, so those are the three main things in this chapter. Okay, there is the difference between two proportions, population proportions. There's a difference between two independent means. And I didn't do one, but you could do it with data also. If you go back to the calculator, by the way. Oh, by the way, I have also, I did the subtraction to show when you're doing the difference between two independent means, you're really doing a hypothesis test for one variable because it's the variable for the difference when they're dependent. So there's your variable data, single variable data. But if I go back to the calculator, and I'm not going to do one of these just to save time, but I want to show you. There's also a hypothesis, there's a two independent samples with data. It looks very similar to what we just did. That would be if they're independent instead of dependent. Any questions on that? So that would be something like, I don't know, let's say you wanted to look at GPA of college students at Lake Tahoe Community College versus GPA of college students at, say, San Francisco City College. And you asked, 50 students at San Francisco City and maybe 50 students at Lake Tahoe Community College and looked at their GPAs. That would be independent because a student at LTCC has nothing to do with a student at San Francisco City College. Does that make sense? They're not paired at all. Is that clear?
Yeah.
Okay. And that would be this particular calculator. Okay. Pairing also happens a lot again when it's two different. If you did a survey of say 35 people, asking them, say, how long it takes them to commute to work, and how long does it take for them to get back home from work, then that'd be very paired because each person has a how far to and how long to and how long back home. Does that make sense?
Yeah.
Okay, so that's very common with the paired is when it's asking each person two questions. Okay, that you can subtract the answers and it makes sense. Okay, if you ask them how long it takes them to commute to work and how much money they spend on gas, say per week, could you do what we've done?
I don't think so because
No.
they're like not that, they're just kind of correlated, right?
Right. You can't do what we've just done because one of them, first thing, the units of the first one are hours or minutes, right? And the units of the second one are dollars. They're not even the same units, like not even related to the same units. Does that make sense?
Hmm.
So comparing them that way makes no sense at all. Do you think we'll ever deal with something like that in this class?
No.
One more guess?
Yes.
Yes, in 2 weeks.
Okay, so but that's not going to be for project 2.
No, definitely not for project 2. So I want to emphasize again, even though we haven't gotten to the project 2, I am getting to project 2, is that don't do a survey question where you're comparing something like time to money. because you can't compare them. Does that make sense?
It sounds
Using
like we need to have the same units for this project too.
Yeah, exactly. Gotta have the same units. Okay, so let's continue on. Before we do project 2, any guess on what I'm about to do? Secret word. Okay, and the secret word for this week is difference, because this week is all about doing a hypothesis test for the difference between two means or two proportions. Is that clear? So write it down, make sure you got it. And now let's get into project 2. So I created a timeline because I think it's nice, important to have a timeline. And when I'm doing a timeline, I don't know about you guys, but when I do a timeline, when I have something really important going on, I work backwards because I know when the thing is due. And then I think about all the things I have to do to get there. So you start with when it's due and then go backwards. So it is due on June 8th. So it's not due on June 18th. It's due on June 19th. But why did I write June 18th?
Just in case.
Yeah, when you have something really important and you could turn it in one day ahead of time, do it. And that way, if a disaster happens, you have a day to deal with the disaster. Does that make sense?
Mhm.
So these are goals. So the goal would be June 18th, and it could be June 17th. That's fine too. But I don't recommend thinking, well, I'm just going to do it the night of the, that's when your internet goes down, bad things happen. Okay. They're even talking about issues with in California with electrical outages because of too many people using power. And there's not enough hydroelectric power coming out because we have a drought. So all kinds of things. So again, a day before is a good idea. Okay. And then I suggest around a week or so beforehand to submit the draft. And that's June 12th. And notice there's a lot of time between now and then. And same rules about the draft that we had before. And that is you submit the draft. I'll only read it once, but Braulio will read it afterwards, right, Braulio? Okay. And I'll give you lots of suggestions. Huh? Yeah.
Yes.
Yeah. And I'll give you lots of suggestions. And I have the same timeline for reading it. If it's after 8 a.m. on the Thursday before it's due, I won't look at it. Okay. So you need to do it ahead of time. Okay. Because again, I believe in making sure that people set their agenda and go with it. Last minute is a bad idea. So I'm trying to show you that. By June 5th, I strongly recommend you have your data collected. I'll get into that, what the collection involves in a bit, but that's a good deadline. Okay. Again, these aren't like absolute deadlines, but these are suggestions. These are goals. So that'll give you a week to write the project after you have your data. And a week is probably enough time. Any questions on that? Okay. By May 29th, that's a week before that, and again, this is that means before is even better. Okay. And notice it's the 23rd today. So we're getting there. Is to post your project idea on the project 2 discussion board. And when I say post your idea, what you're going to post is you're going to post your null hypothesis and the alternative hypothesis and a short description. And then I can look at it and give you ideas on how to make it work even better. Does that make sense? Any questions on that? And then by tonight, know who your partners are. I actually told you that like weeks ago, remember? So you should have partners, okay? And again, same rule, 2 or 3 in a group. 3 is a lot easier than 2 for lots of reasons, less work to do per person. And also if something happens to one of the people, then you still have 2 left and you don't get deducted. Is that clear in terms of timeline?
Yeah.
Okay. So far I haven't said anything that isn't different from the last project, right? Other than it has a number 2 and the dates. Okay. So now let's get to the project. Let me go to the syllabus. And let's take a look. Okay, so now we're in project 2. For project 2, students will conduct a survey that constructs a confidence interval and performs a hypothesis test. Got it? Okay, because those are the 2 main things we've been doing the last 3 weeks. Each project will include the results and a narrative describing the data collection, assumptions made, background information, how the data was analyzed, and conclusions. Okay, I'm going to click on this project 2. And here's the requirements. Okay, one I already told you, you have to work in a group. Okay, so the purpose of project 2 is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. Got it? Okay, just like project 1, you're gonna find a client. Okay, and that means in theory, it could be President Biden, and that's fine. I don't expect you to be able to talk to President Biden. It'd be cool if you could, but good luck. But you're gonna have at least a hypothetical client. Got it? If you can't think of anyone that would be interested in your hypothesis, then it doesn't make a good study at all. Is that clear?
Mhm.
Okay, so think about who might be interested, and that's important. Okay. So again, then of course, then you're gonna, before you do the next step, you're gonna like post on the board, make sure it works. Okay, then you're gonna collect your data. Okay, so this is very different than project 1 in that your data collection, you're allowed to use convenience sampling. You must be honest. That's all I asked for. Got it? So if you use convenience sampling, say that you use convenience sampling. Okay, and you won't lose points. If you use stratified sampling, say you stratified sampling. Whatever sampling you used, you need to tell me what you did. Okay, is that clear?
Okay.
Okay, so just write it in your project. Okay, so sounds good enough?
Mhm.
Okay, a couple notes. You don't have to survey people, and I said that at the beginning of this webinar, but now I'm going to repeat it again. You can collect data from a source. Got it? Okay, we have the same rule as project 1. If you can easily collect a census, do you remember the word census? Do you remember what that means?
Mhm. That means everybody.
Right. If you can not, without that much effort, get the data for everybody or everything, right? If it's things instead of people, then this will not work for project 2. Because if you know the population, there's no reason to ever do a hypothesis test or a confidence interval because you're 100% confident. Does that make sense?
Oh, okay.
Okay, so it has to be, so the population better be very large. Got it? Like way larger than you could ever do with a study.
Okay.
And that's why things like Amazon, how many products does Amazon sell?
Millions.
Millions.
Millions. There's no way you're going to be able to, in a decent amount of time, get the price of everything Amazon sells. So that's why that could work. Does that make sense?
Yes.
Or
Yeah,
all community college students in California. Okay. How many of them are there?
Millions, probably.
Millions again. Yeah. So you got to make sure that you have a population that's very large, like way larger than you could ever sample. Does that make sense?
Mhm.
Okay. Your sample sizes must be both more than 30. And hopefully you understand now, unlike project 1, where you didn't understand why I told you had to be over 30, but now you better understand why over 30 is important.
Normal distribution.
Yeah, yeah, because otherwise you pretty much have somewhat useless data. Okay, so you have to have over 30. And so if you were doing like in the example, Amazon versus Costco, make sure you have over 31 products that you're going to be looking at Amazon and Costco. Or let's say you're going to be looking at men versus women for their, I don't know, how long they spend studying for stats. Then you got to make sure you can survey 31 men and 31 women. You could do 31 men and 38 women. That's fine. But they both have to be more than 30. Does that make sense?
Mhm.
Okay. And that would be an example of independent samples, right? If it was just male students versus female students. Does that make sense? Any questions so far?
Nope.
Okay, so you should write down, make sure you have your hypothesis written down. There's an order at which you must do things. Okay, step one after getting your partner, by the way, is come up with your H naught and H1. Okay, this is before you collect your data. Then you post it on the discussion board. I check it out, make sure it's good. Step two, decide what your type 1 and type 2 errors are, how bad they are, and who would get hurt. Got it?
Okay.
That's before you collect your data. Okay, so it's what we talked about last week in terms of the order at which you do things. Step three is you look at your type 1 and type 2 errors. And then based on the type 1 and type 2 error, you decide what your level of significance is. Any questions on that? This is before you collect your data, and it's important that it's before. Okay, any questions so far? So notice that before you even collect your data, you can write several paragraphs of your project. All that can be written out and should be written out before you even collect the data. Any questions on that? Okay, the next step is collect your data. Sound good?
Mm-hmm.
Okay, so collect your data, and it's great if you can do that with your partners, but if only one person collects the data, that's okay. But might as well share the wealth, right? Share the work.
Mm.
Okay, after you collect your data, what do you think the next step is?
Write the paper.
What's that?
Write
Put
the
it in the
paper.
calculator.
Yeah, put in the calculator, but not the calculator we've been using. Remember, with the projects, what's the requirement?
The spreadsheet.
Spreadsheet. So the good thing for you guys, by the way, is that I made the spreadsheet do, by the way, the spreadsheet does everything in our class. I don't know if you realize that. So the spreadsheet that you used last time automatically went to this page. Is that clear?
Mm-hmm.
But this isn't project 1 anymore. Any guess what I have to do so that we can get to project 2?
The tab on the bottom, 2 variable statistics.
Exactly. I tried to make it easy to read. Tab on the bottom, 2 var stats. Click on it. And there we go. So I just called it first and second. Okay. And by the way, if you've already copied my spreadsheet, made a copy of it, then you don't have to make a copy again. Just use it again. You got your own. Does that make sense?
Mm-hmm.
Okay. So you got first and second. Okay. You just type in your data values for the first and second. You can give them names if you want. That's your choice. Okay. And then you don't have to click anything, actually. All you have to do is move your eyeballs. Got it?
Mm.
So what's important is you need to know, are you using dependent data or using independent data? Is that clear? And if you're using independent data, it's all this stuff. Do you see that? J and K. If you're using dependent data, it's N and O. Is that clear?
Yep.
Okay. And it has a p-value, two-tailed, right-tailed, left-tailed. So you just have to move your eyeball to the right one, depending on what your hypothesis test is. It has a test statistic, the t-value. And then you have to type in your level of confidence. So right now it says 90, okay? And let's say you wanted 99. Hit enter. And that changes the, you have to wait a second, and now it changed the lower and upper confidence intervals. Any questions on that? So what you're going to want to do, depending on whether it's dependent or independent, is you're going to have to look at this. And you should look at the 99. You should look at the 90. And you should look at the 95. And then based on the upper and lower limits, There's going to be pros and cons for each of them.
Hmm.
You're going to write a little bit about the pros and cons, and then you're going to choose the one that's the best for your client. Remember, a pro of a 99% is that you're much more confident, but the con is that you have a larger interval, so you have less information. Do you see that? The pro of a 90% is that you have a narrower interval, so you have better information, but you have a higher chance of being wrong. Does that make sense? So here's what you should not do, and a lot of people make the mistake on the project. Do not say, I used a 5% level of significance, so therefore I'm using a 95% level of confidence. They are not tied to each other. Is that clear?
Hmm.
You could use a 5% level of significance and a 99% level of confidence. Okay. Level of significance is for hypothesis testing. Level of confidence is for confidence intervals, and they're not tied to each other. Got it?
Mhm.
Okay. So just a note there. By the way, if you're doing dependent difference, it's over here that you're going to put in your confidence level. So maybe 0.99. And then wait a bit and it'll just show up. Any questions on that? Okay. Do you remember the standard error?
Yeah.
Yeah.
We talked about it. The standard error is as important as the standard deviation was for project 1. The standard error is that important for project 2.
Yeah.
And that's the hardest part of the project. I want to give you a warning.
Oh, why?
Because you have to fully understand the standard error.
Well, I mean, isn't it enough to say that the standard error is the standard deviation of the sampling distribution? Oh,
Yep, that's what it is. That's the definition. How does it affect a client? After looking at this number, what decisions might your client make? Do you see? And how does it relate? Is it a small enough number for your confidence interval?
well, I guess it determines, well, I'm sorry, the small enough level for my confidence interval.
Sometimes it depends on your particular study.
Right.
Does that make sense?
Mhm.
Okay. And was it small enough for you to be satisfied with your hypothesis test?
Hmm.
Okay. And the satisfaction has to do with that soccer example that I gave you.
Hmm.
So if you had a 0.04 for your p-value, you're very satisfied, right? You're good. If you had a 0.06, you're like, crap, this is horrible. My standard error was too big. Do you see that?
Uh-huh.
If you had a 0.9, you're like, well, I wasn't able to show what I wanted to show, but my standard error was small enough. Do you see that?
Yeah.
If you had a 0.001, your standard error is definitely small enough.
So the smaller your standard error, the smaller your p-value is going to be. And
Not necessarily,
okay.
because let's say you did a study to find out if there's a difference between I don't know, how about GPA at Lake Tahoe Community College and GPA at San Francisco Community City College. Got it?
Okay.
Well, if the GPAs were the same, then you're probably going to have a very high score
Okay.
because the high p-value is going to say, oh, you know what? Looks like they might be the same. Do you see that? You don't have evidence to say they're the same, but the p-value is going to do, it's going to move it with a very large sample size and a small standard error. It's going to move to the truth,
Uh-huh.
right? And if the means were equal, the truth is going to make the p-value much bigger. Do you see that?
Oh, yeah. Okay.
Do you see
got
that?
Yeah.
Okay, so it's very important. Just a note, let me show you. That is here. Okay. So I have a video on the standard error because so many people have so much trouble. Please watch it. You just click that and it'll give you the video. It's YouTube. Okay. And it gives you some thoughts about standard error. Got it?
Okay. I mean, I know you only read the project once, but can we post little snippets of our understanding on the project 2 discussion board?
You can post questions about it.
Okay.
Don't post like a whole paragraph and say, do you like my paragraph? I know you already read it. That's not okay. But you can ask Robin to read it. Okay, that's my rule. I don't read it over and over again. But if you had a question about something, I can answer your question. Does that make sense?
Okay.
Okay. So just to note, it's very important, just like project 1, that your entire project talks about the decisions your client might make based on the finding.
Mm.
So after seeing the p-value, what decision might the client make? Okay. After looking at the lower bound for the confidence interval, what decision might the client make? After looking at the upper bound, what decision might the client make? And they're going to be different. Make sure you separate lower and upper bound. Does that make sense? Don't just put it all in one sentence. This is a paper, so it's like paragraphs. Okay. After looking at the p-value, revisit the type 1 and type 2 errors. One of them is no longer going to have any relevance whatsoever. Because if you reject the null hypothesis, the type 2 error can't happen. If you fail to reject, the type 1 error can't happen. Does that make sense?
Yep.
Okay. And then based on those errors, say, well, is it likely or not likely to have that error, the one that could happen? And like that example with a bunch of zeros and a 1 for the p-value, it's very unlikely for a type 1 error. Do you see that?
Mm.
And it's impossible for a type 2 error.
Mm.
Okay, so make sure you revisit the type 1 and type 2 errors. Okay. And again, talk about with your client, what your client might do with it. Is that clear?
Mhm.
Okay. You can either do dependent sample or independent sample. Make sure you talk about which one you're going to do. Okay. You can't do proportions. And that's because for good data with proportions, you really need like 1,000, and that's too much work. Does that make sense? For sample size? Okay, so that's not, so make sure it's either going to be a 2 sample tests that are dependent data or 2 sample that are independent data and means. Is that clear? Okay. And again, think about what a data value might be. It better be a number, and then another number for the next group. Does that make sense? Any questions so far? Okay. So the main things you're going to be doing is talking about hypothesis test or confidence interval. That should be most of your paper, by the way. Okay, if your paper is 50% other stuff, that's not right. Okay, it should be mostly hypothesis tests and confidence intervals. Got it? You could talk a little bit about other statistics, especially maybe the means. That's the only thing that might be that interesting. But you don't have to get into all the different, don't get into quartiles and stuff like that. That was project 1. So this is not project 1. Okay, is that clear?
Wait, don't get into what?
Like quartiles.
Quartiles. Okay.
That was project 1. Okay, but you can get into means because your hypothesis is about the difference between means. So talking about the 2 means makes some sense. Does that make sense?
Yeah, so far I'm not seeing any graphs that are needed. Is that
No graphs are needed.
okay?
Yeah, no graphs are needed. In fact, if we look at the spreadsheet again, do you see any graphs here?
Nope.
Nope. Yeah, no graphs needed. This is not project 1. Don't try and make it be project 1.
Okay.
What you need to do, and it is an absolute requirement, if you're doing independent data, then copy and paste it in your project. J and K, got it?
Okay.
If you're doing dependent data, copy and paste N and O into your project.
Okay.
Is that clear?
Yep.
Okay, there. Okay, and then you should do a little summary. And that summary should talk about, what the final decisions for your client are going to be. If you could do a study with, Do you suggest a bigger sample size? That has a lot to do with the p-value, remember? Those are the kind of things, if you were to ask more questions, but what questions might you ask? And by the way, in the real world, you always do that, especially if you're getting paid. Do you know why?
Mm,
So that you get more money for being hired again to do more stuff.
okay.
Whereas you say, oh, there's nothing left for you to have me do, then that's the end of you making any money. Does that make sense?
Uh-huh.
And you have a client, you can pretend they're paying you. Okay. Any questions on this? Okay. By the way, MSc is Braulio, but you can also use tutors that are, not Braulio. Math Success Center. Just let you know that. So that's pretty much it. Same kind of way of submitting your project, that you're going to submit it via email for your draft. And then for your final project, when it's, time to turn it in, that's on Canvas. And make sure that the names of each person in your group are on it so that I give you the same, grade for everyone gets the grade.
Mhm.
Okay, so that's the same. Any questions at all about the project? Hopefully I answered anything you needed, but you can always post on, let me remind you. We have a discussion forum. You can always post on a discussion forum. Any questions? And of course, your idea. Okay. And if someone's looking for a partner, which someone is, then if there's only two of you, please say, hey, why don't you be a partner with me? Does that make sense?
Yeah.
Okay.
Okay.
And if you need a partner, make sure you post. Say, I'm the one. Pick me. Okay. I think I'm going to stop the share. And I'm going to stop the recording.
Okay.